Welcome to Pomodoro Joe for Saturday, April 8th, 2023. Today we're doing LeetCode problem 133, clone graph. This is a medium problem. Given a reference of a node in a connected undirected graph, return a deep copy or clone of the graph. Each node in the graph contains a value, int, and a list of nodes, of its neighbors. And the class is a node, has a value and some neighbors. There's some test format information, which I won't go through. You can read that on your own if you want. And that's about it. All right, so we need to make a deep copy of this graph, which means that we need to make a deep copy of each node. So with that, we'll put 25 minutes on the Pomodoro timer and get started. So clone graph is basically the same as saying clone this node and all of its neighbor nodes. So let's see, internally I'm going to make a helper function. This might not be necessary, but I think it's going to keep things a little bit cleaner. So I'm going to have this helper function for cloning an individual node. And let's see, we'll pass in the new node or the node we want to clone. So I'll call it N because I don't want it to conflict with this node. Now in our clone node function, it's just going to clone the node and return it, which really is the same thing that this clone graph is doing, but I think we're going to need some external helpers, so let's start with this. Okay, so what do we do when we clone a node? Well, we'll have a cloned node, or I'll call it a new node. That's just going to be a node. And let's see, we'll need its value to be the same as this node's value. So our new node.val, that will equal our nodes.val. Now what happens if our node is none? Let's make sure we handle this base case. So if n doesn't exist, we'll just return none. So we're handling our base case. If we have a real node, then we'll create a new node, we'll set its value to be the same, but now we need to make clones of all of the neighbor nodes. So for neighbor, in this nodes, the input nodes, neighbors, well, we'll need to make a clone. So we can say new neighbor. That's going to be, well, we'll just call our clone node on the neighbor. And then we'll add this new neighbor to our current new node's list of neighbors. So our new node, neighbors, will append this new neighbor. All right, so now we've cloned the node. We have a new node with the same value and a set of all new neighbor nodes. We'll return our new node. Now, one thing that is going to be a problem here. So we're going through and we're cloning these neighbors. Now, it's certainly possible that we have the same node, or we'll have different nodes that point to the same neighbors. So let's say I have two nodes that both point or have a neighbor that is node 2. Well, that means I'm going to clone node 2 one time for the first node, and then I'm going to clone node 2 a second time for that second node, which is going to be a problem. We're going to have multiple clones of the same node. So I don't want to just clone the node. I want to make sure that I haven't already cloned the node. And if I have already cloned the node, then I want it to point to the same cloned node. So we're going to need some way to do that. We'll need some storage where we're going to keep all of our cloned nodes. So out here, let's keep track of all the nodes we've cloned so far. So we'll have a cloned nodes dictionary. So what this dictionary will hold, well, the key, that's going to be some node ID. Now in this case, that's just the value contained in that node. All right, and then the value, let's see, the value is going to be our new cloned node. So now we have a way of mapping our node ID, in this case the value at that node, to our new cloned node. So that means down here, instead of just cloning the node, let's see if we have the cloned node first. So let's see if this neighbor, all right, so if this neighbor's value is already in our cloned nodes dictionary here, that means we've already cloned this node, so we don't need to create a new one. Okay, it looks like I'm going to need to keep some track outside of this. So I'll have a new neighbor, and we'll start it equal to none. If we already have this neighbor cloned, well then we can just say this new neighbor is equal to the cloned node for this key. I'm going to actually do this a little bit differently. Let's do this in a way that is a little bit cleaner. It might be less runtime efficient, but I think it'll make things cleaner. All right, so this node ID, let's see. So our new neighbor will be none to start with. Then we'll see if this node ID is in our cloned nodes, well then our new neighbor will just be the cloned node at this ID. Otherwise, well, at this point, we'll have to create a new neighbor. So we'll actually have to clone this node. So we'll clone this neighbor node, put it in new neighbor, and then we'll add our new neighbor to our neighbors list. All right, let's see if I got this right. So for every neighbor in our neighbors list, we'll grab the node ID, which is just its value, and we'll check to see if this node is already in our cloned nodes. If it is, then we're just going to grab that node out of our cloned node dictionary. Otherwise, we will clone this node, and then we'll add this node to our dictionary. All right, so if we have to create a new clone, we will make a clone of this neighbor, and then we'll put that new neighbor clone into our cloned nodes dictionary, and then we will add that neighbor to our neighbors list. At the end, we will return our new node. All right, so this clone node function is done. We pass in a node, it will make a clone of that node, and it will be a deep copy. It will clone the node itself and all of its neighbor nodes. It will only create new clones of the neighbors if it needs to, otherwise it will get them out of the cloned nodes dictionary. So at the very end, outside of this cloned node function, in our main clone graph function, we'll just return a clone node of the node that it's passed in. Okay, so I think this should work. Let's give it a shot. Maximum recursion depth. Let's see what's going on here. So if the node is none, we'll return none. Otherwise, we'll create a new node, and the new node's value will be the n value. Okay, that seems fair. Then for every neighbor in our neighbors, oh, I think I know what I'm doing wrong. So here, we're creating this new node, but we haven't added it to the dictionary, which we probably want to do. So let's add this to our dictionary as well. Okay, I think that should fix this. Let's see, cloned nodes. I think it's plural, yep. Okay, try that again. Okay, that seems to work. Let's see if this will pass all the text. And we pass, and we do pretty well actually. So we beat 89% for runtime and 65% for memory. That's pretty darn good. Well, we have a little bit of time left. Let's see if we can make some improvements here. So I like this cloned nodes. That's pretty straightforward. I like this. So one thing we could do is set the val directly in the constructor. So let's do that. That saves us a little bit. And we'll still add it to the cloned right away. What else can we do? Let's see. Well, this we set none to start with, and then we have this conditional that will potentially set it to something new. We can clean that up a little bit. Yeah, let's clean this up. So instead of saying the new neighbor is none right away, we'll just say the new neighbor will be our cloned node's neighbor if the node ID is in our cloned nodes. Else, then we'll have to create a new clone. All right, so this does the same thing. It's going to say our new neighbor will be the cloned nodes at this node ID. If the clone node ID is in cloned nodes, otherwise we will create a new clone of this neighbor. So it's a little bit more Pythonic this way. All right, and this node ID we don't actually need because it looks like we only use it once here. Actually, is that true? Yes. So previously, there's one thing I didn't do. So previously, we will also add our cloned nodes directly into our cloned node dictionary, but now we're doing it up here as soon as we clone the node, so we don't need to do it again down here. All right, so that should clean that up a little bit. We'll still need to add that node to our new neighbors, or to our neighbors list. And this node ID, we don't actually need, but I'll keep it because it's clear. All right, let's see if this still works. It still works. Let's see if this saves us anything. It actually does far worse. Now we're only beating 60% for runtime and 65% for memory, whereas before we were almost at 90%. Wow, that is surprising. I wonder which of the changes that we made were the things that slowed us down. Is it this if, or is it this constructor? Let's try changing one at a time. All right, let's see if this will do it. So that might have been it. Takes us back to an 89% for runtime. Drops us down in our memory though, which is interesting. So looks like trying to pass in values in the constructor actually slows us down, which I find very surprising. It was at this point I really just wanted to boost our runtime just a little bit to get over that 90% mark. I did all kinds of time-saving measures, changing variable names, changing how we did the calls, changing the entire function to be moved out into the class itself. Nothing could bump us up enough to get over 90%. So 89% was my best score on this one. I would say there's definitely ways to improve, so please check this out, try it on your own, and see if you can get a better score than I did. All right, well that is it. I am done. I'm out of time. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.